Alrighty. So this lesson is about transformations, okay? And we're going to be looking at 3 different types of transformations. And this is really kind of our one transformations. I teach transformations in 8th grade as well, 8th grade math, but this is more focused on transformations to linear equations and quadratic equations. So the main thing when we're talking about transformations to linear equations is that we're talking about how does it transform the parent function, which is f of x equals x, okay? A line that has a slope of 1 that goes through the origin. So what have you done to the function to obtain your new function? And there's 3 options for that. The first option is a translation, which is just a slide, okay? Slide up, down, left, right. We consider it a vertical translation, which is a slide up or down, if you are adding or subtracting an amount, okay, and it's not inside of a parentheses. If you're adding, you go up. Subtracting, you go down that many units. Left or right occurs when you add or subtract inside of a parentheses, and it's kind of opposite of what you think. So you would think if you subtract, you go to the left, but it's totally opposite. If you're subtracting a value inside of the parentheses, you go right that many. Adding a value, you go left that many. The next option of something that we can do is to dilate it, which stretches it or compresses it. And basically that's when you have a coefficient on x. If you do not have a parentheses involved, and you just have a 3x, a coefficient and x, if that number is greater than 1, you have a vertical stretch. If it's between 0 and 1, so like 1/2, 3/4, 0.8, then it's a vertical compression. Now, if you have a parentheses and you have a coefficient of x within inside of parentheses, this is a horizontal translation. Greater than 1 is a compression, between 0 and 1 is a stretch. So it's just completely opposite of your vertical. The third option is a reflection, and this all has to do with negatives. So if your coefficient of x is negative, then there's no parentheses involved, then you are reflecting across the x-axis. If your coefficient of x and you have a parenthesis, or your coefficient of x is negative and you have a parentheses involved, you reflect over the y-axis. Okay, so feel free to pause and look at these notes, copy these notes if you do not have them, to help you, because to do these problems, we're going to totally rely on these rules. So let's look at a few of them. Looking at number 26, it says describe the transformation. So we don't have a plus or a minus. We don't have a slide. We have a coefficient. That coefficient is negative, and that coefficient is in the parentheses. So I look and I find a coefficient inside the parentheses is a reflection across the y. So reflect over y-axis. And then this is also a dilation because you have a coefficient here. And so I go and look, this is inside parentheses, so it means it's going to be a horizontal dilation. This number is in between 0 and 1, so that means it's going to be a stretch. And I'm looking totally at my notes that I just had up on the board. So I write stretch horizontally. Okay. Let's look at, let's look at number 29, okay? So this is a negative. We're going to have a reflection of some sort. There is no parentheses involved, so it means it's over the x-axis. So we're going to reflect over x-axis. And then look at the number. There's no parentheses involved, so this is going to be a vertical dilation. It's greater than 1, so it's going to be a stretch. So a vertical stretch. And we have this -5 that is not in parentheses, so this means it's going to be up or down. And since it's negative, then we slide down 5 units. Okay, I'm going to do one more like this with you, and then I'm going to move on to another idea because I've kind of went over every different transformation here. Now this one not, is this coefficient here for x is not negative, so there's no reflection. It's on the outside of the parentheses. So this, I look at my dilations and I look on the outside of parentheses. I look for between 0 and 1, so this is a vertical compression. And with inside of my parentheses, I have a -3. So this is going to be a horizontal translation. And remember, when I said when it's horizontal, it's opposite of what you think. So minus is going to be actually in the right direction. So vertical compression, slide right 3 units. Okay, so I hope that helps you on any of these types, because I kind of did ones that had all of them in there. So hopefully problems that you will do will be even easier than these. Now let's look at a different type problem that my algebra book is asking my students to do. So look at number 10. It's asking them to write a function represented by the graph, and the way that they're wanting them to do it is kind of compare it to the parent function. But that's kind of a little crazy. We have a much easier way to do that, and it's simply y equals mx plus b. Give me the m, give me the b. Okay? The m is rise over run. So I picked 2 nice points. So find places where your graph goes through a corner. Okay? And looking here, I don't really have that. So this is pretty obvious on number 10. If I zoom in, that on number 10, it kind of goes through a half block here, and it kind of goes through a half block here. So even though I don't have really 2 nice points like I define it, these are pretty nice because I know they go through a half block. So if I'm looking at my rise, I go up 1, and then I take a right turn, and I go from -1/2 to +1/2. So my rise is 1 over 1. And if I look to see that point right there, my B is where does my line cross my y-axis? It looks to be at about -1/2. Okay? So putting everything into its spot, I have y equals 1 over 1, or just 1x minus 1/2. So really, the only, and I can take away that 1 because I don't usually write that coefficient of 1. The only transformation that this has to my parent function is down 1/2. Alright, the last one I'm going to look at is how in the world can we relate a word problem to transformations? Well, we can. So Jerome is buying paint for a mural. The cost of the paints can be modeled by F of P, $6.99, where P is the number of paints he buys. He has a coupon for 15% off of the original cost. Write a function that represents the cost with 15% off. Well, this means, y'all, that he's going to pay 85%, because we talk about percent being out of 100. So $6.99 per paint that he buys. This is what this means. He's paying $6.99 per bottle of paint, or whatever, can of paint. Well, he's going to pay 85%. He's going to get 15% off of it, which means he's going to pay 85% of the original cost. You always take that percent away of that 100%. So 100% minus that 15% leaves us with 85% of the original cost he's going to pay. And to write, we don't put 85, we always write it as a decimal. So I'm going to do 0.85 multiplied by my original function of 699p. And this equation is going to model, and it says write a function n of p. So I'm going to erase my a so I can. So n of p equals 0.85 times 699p. Now, find the cost of purchasing 5 paints before and after the discount. So, before the discount, it was f of p. So, f of 5 equals $6.99 times 5. And n of p, which is what they called it after the discount, equals 0.85, parentheses, $6.99 times 5. Alright, we plug those values into our calculator. $6.99 times 5 gives me, so f of 5 gives me $34.95. And n of 5 gives, you do 0.85. Type it in exactly like this, parentheses, 6.99 times 5. And we're going to round, so we'll do $29.71. Okay. Short but short and quick, but I hope informational and helpful.